Hello all, my name is Jayasri, working as Assistant Professor in the Department of CSE AIML, MLR IT. Today, in this session, I would like to discuss about implementation considerations in cognitive computing. How do you implement the application in cognitive computing? How do you implement it? What is the correct procedure, or what is the correct way of choosing the implementation level? Choosing the right neural network architecture. We have different types of neural networks. We have FFN, FNN, CNN, RNN, and we have something called NLP, BERT, so on. So let's see let's see all these neural networks in gist. Okay. Different types of neural networks are FFN. What is FFN? Feed forward neural network. Feed forward neural network, which is used in basic pattern recognition. Pattern recognition, feed forward neural network is something that it is only for forwarding the neuron from one neuron to the other neuron. Okay, this is done only in the forward manner. There is no backward manner. Okay, it doesn't support the back propagation. Cognitive convolution neural network is used to choose the best for image and video processing. CNN is used best for images and videos. Okay. RNN is a recurrent neural network, and LSTM is a long short-term memory which is used in speech and language processing. Okay. So speech tells that you give audio to text. Okay. So here when you are speaking something, it converts into text and it converts into text. So this is again related to language processing. And also it talks about transformer models. Transformer models like Power AI chatbots and NLP system. NLP system is gives an example of ChatGPT and BERT, so on. And here the basic considerations are it defines the problems and data types before selecting the architecture. And it also uses CNN for image related ICT applications and RNN or LSTM for text based applications. So here if you see the framework, conceptual framework for cognitive model design, I have a personalized cognitive model. Which is having different iterative processes. It has different iterative processes of model designing and empirical evaluation. It evaluates and it also gives the revision for. So here the personalized cognitive model will give you the research question. Okay. Now this research question will inform to the domain sustainability. It gives a research question and it informs to the domain sustainability that there is something related to, or it is having a relevant level of analysis section, and it's having a cognitive model paradigm. Also, it is having a computational properties of model systems. So these three relevant levels of analysis, cognitive modeling and conceptual properties are defining the whole domain sustainability, and they are giving back to personalized model. Now here domain sustainability is again informing to cost-based decision, where the researcher have some kind of resources where he can support in giving the inputs. So this is the cost benefit decision. This again the input given to personalized cognitive model. This decision is given to start the model iteration process based on sustainability of the domain, which is related to researchers' resources. Okay, so here, based on the researchers' resources, he is informing to the cost-based decision that it's having some input which can help. Again, this data which is received from the research resources, that data is sent to research question again. Okay, and this model continues until it gets a perfect framework. It is having a perfect conceptual framework until it gets a particular frame. Now, if you're talking about the hardware and computational resources, it requires high computational power, and here we have implementation conditions like GPU, CPU, graphical processing unit, and tensor processing unit. Now, GPU are faster for deep learning, and tensor processing unit are optimized for AI workloads. And along with this, we have cloud and on-premise computing. Cloud platforms like AWS, Cloud Computing, Azure offers scalable AI training. And on-premises setups, it provides more control over data securities. It also chooses hardware based on network complexity and the data size. And the cloud computing for large-scale AI applications, it uses cloud computing for large-scale AI applications. What is the quality of data? Quality of data is crucial for neural network accuracy. And these are the steps for it. First is data cleaning, feature scaling, augmentation, hyperparameter tuning. Data cleaning, it removes duplicates or incorrect data. Feature scaling, it normalizes data for consistent learning. And augmentation is it improves model performance using image or text augmentation techniques. And hyperparameter tuning is it chooses the right learning rate. Optimization batch size is, say you have batch size of 2, number of epochs 2, then it optimizes to 1, right? So yeah, it uses dropout layers, it uses regularization, and it uses data augmentations. Here, when you are checking out for key considerations, we have high quality, well performed data, which leads to better AI performance. And also, it has a hyperparameter tuning, which improves the training efficiencies. Next is model deployment and real world applications. Deployment model talks about on-device AI. On-device AI is talking about the mobile AI, edge computing for real-time applications, and cloud computing AI for scalability and storage. Now, here the challenges are it have a high latency in real-time application, and the data privacy concerns are there when you are using a cloud AI. So, what is the solution for this? The solution is it optimizes AI models using model compression, nothing but pruning and quantization. Okay, it uses edge AI to reduce the latency. Now, in this session, what are the key takeaways here? Is that you choose the right architecture. You are choosing the right architecture, which is essential for performance, and it is having the efficiency hardware selection. It can efficiently select the hardware, which improves the processing speed. Okay. Next is data pre-processing and hyperparameter tuning optimizes the accuracy. It optimizes the accuracy. Next is model deployment. Model is deployed based on the strategy which impacts the real world AI applications. It impacts the real world applications. Thank you. I hope this session is clear for you. Thank you.